Welcome everybody to testing like you've never tested before, because you haven't. For those who don't know me, my name is Steve Grunwell. I'm at Steve Grunwell on all the social networks that matter. And if you want your own copy of the slides to follow along with, you can grab them now at stevegrunwell.com/slides/intro to testing. It's also very small, but at the bottom of each and every slide. Come on, voice, let's get through this. All right, so before we can really talk about automated testing, it's important to understand the role that automated testing plays in software development. So through automated testing, we're able to codify our exact testing procedures. This is going to reduce the chance that someone's forgetting a step, or someone just goes, oh, I didn't have time, so I just kind of wait. It'll probably be okay. It also makes our testing very reproducible. Everyone is running the same steps every time because it's codified. It's something that you say, hey, run tests, and it goes, great, let me run everything that we've scripted out. This reduces the chance of someone, say, forgetting a step or whatever. This is going to be really vital as you start moving toward that holy grail of continuous integration and continuous delivery, also known as CI/CD, so that we can build and deploy with confidence. Hooray! There are a few different types of tests, and depending on who you talk to, people categorize these in different ways, but for the sake of this talk, we're going to look at them thusly. At the most simple test, we have the noble unit test. This is going to test the smallest possible unit of your application. Now, unit can be kind of a subjective measure, but typically this is going to be, okay, I'm testing a single function. I'm testing a single class method. If I give it, A and B, I'm expecting to see C from it. Moving up, we get to integration tests, and these take how these individual components or units interact with each other, how they integrate. Ha, clever. Within Laravel specifically, a lot of times the integration tests are going to fall under the /test/feature directory, where you start going, okay, I'm focusing on the feature as a whole rather than just on the individual unit tests. Then we can get higher up and we can get what are known as end-to-end testing. Because this is a Laravel Meetup, Dusk. This is where Dusk comes in. You're often scripting a headless browser. You're saying, okay, as a user, I'm visiting this page, I'm clicking on this link, I'm inputting this text, clicking this button, and expecting this to happen. This is sometimes called full stack testing, and while it can be really powerful, it's also kind of its own amorphous thing. So we're going to consider that beyond the scope of this talk. We're going to be focusing on the first two, unit and integration tests. With these types of tests, they're often arranged in what is known as the automation test pyramid. The idea being, at the bottom of this pyramid, the x-axis here is going to represent the number of these tests that you have, and the y-axis, the cost of writing and executing those tests. So, at the base, we want a strong base of unit tests. We want to make sure that all of our functions, all of our methods, they're behaving the way we expect them to. Next, we're going to move up to integration tests. A little more involved to write, still very important, and this is where you start making sure that all of those individual components are actually cooperating the way you expect them to. Up at the top, you have what's known, or that's where the end-to-end testing would lie. Because these often are more involved to write, because you're often, say, driving a headless browser, they're going to take longer to run, it's going to be a little more painful. Typically, if you had to decide where to focus your testing efforts, if you're working on a legacy application and just saying, we have no tests and we want to get some stuff around it before we refactor, you might actually work top down and kind of say, okay, end-to-end, what are the key paths that we have to have? Because unit testing a function that may just get thrown away might not be as effective. But if you're building an app from scratch, or if you're adding a new feature to an existing application, you'll typically want to start at the unit test and then work your way up as time and budget allow. An example of a very simple unit test would be something like this. Let's say we have this helper function called format currency. It takes an integer of cents, an optional prefix that defaults to the United States $, and it returns a string. God, I love type hints. I have a sister talk for this that's all about confidently testing WordPress, and I have to dumb down all of my code, and I'm like, nope, no type hints, no. It's rough. But in our function, we'll say, great, we're going to take the prefix, we're going to concatenate it, use number format to make sure that it's rounding off and we're not getting $52.469 because that's not how we talk about money. A test around this. Whoop. Come on, Bluetooth remote. You can do it. I believe in you. May look something like this. So we have our test method named test format currency applies prefix. We're going to capture the result of format currency when we give it 525 cents with the prefix of USD space $. We would expect to see USD $5.25. Pretty straightforward, right? We're giving it known inputs and checking to make sure that the output is what we're expecting. That's a very simple yet very effective unit test. If someone comes in and say they add an extra space in here because they're like, well, what if people don't think to add the space between the prefix? Then this test is going to start failing because you're not getting what we're expecting. Now, this is an example of a meme very popular on testing Twitter, which is very much a thing, called unit test passing, no integration tests. The idea being, there are probably unit tests around this. Can someone throw paper into the trash can? Yes, they can. When you wave your hand under the hand dryer, does it turn on? Yes. Those individual unit tests passed. No one said, hey, when I put paper in the trash can, is it going to trigger the hand dryer? Hair dryer is a very different thing. So these are more just fun GIFs to have. Some of my favorites are like when you have the sliding doors and then someone's like, oh, look, it locks, but it's a slider instead of like an open on an axis thing. Wow. This cold is killing me. All right, but tea makes everything better. Coffee makes everything better than that, but as we write our tests, regardless of whether we're writing unit tests, integration tests, end-to-end tests, anything, we're typically going to follow this pattern. I'm sorry, I'm getting ahead of myself. Let's take a look at an integration test before we get into the pattern, but see if you can pick up on the pattern first. I'm really glad I'm not on camera right now. All right, so let's say we have maybe a blogging platform. And we want to make sure that when we call the post's endpoint, it's filtering it by the post author. So imagine I've created some just factory functions to generate test data, perhaps using something like Faker. So generate authors, I want to create Bob and Alice. I'll save them to variables named after themselves. And I'm going to give Bob 2 posts, and Alice is a better writer, and she has 3 posts. So when I then make an HTTP request to the /posts !author equals and then Bob's ID, I'm expecting to see Bob's 2 posts. If I see 3 posts, I know at least one of Alice's is getting in there. If I see 5 posts, I can tell, well, clearly this isn't filtering it and only showing me Bob's posts. I could take this test a step further, but for the sake of brevity did not, to say I want to make sure that I'm only seeing the IDs that correspond to Bob's posts. But that would have made the test just a little too big for the slide. So that's a very simple integration test. We start setting some stuff up. We actually make an HTTP request, in this case, and then we make some assertions. Did anyone pick up on the pattern? Or does anyone know the pattern and just want to seem super smart? All right. It's known as arrange, act, assert. As we write our tests, we're going to start by arranging or setting up the scenario. Acting, so executing the actual code that's the system under test, which we'll talk more about in a second. And then we're going to make assertions, making sure that things happen the way we expected them to. In practice, this might look something like this, and this is very topical considering there's pizza right in this room, which doesn't normally happen when I give this talk. So, we're building a pizza app, because who doesn't want to build a pizza app? Build what you love, right? So, we're going to arrange our pizza. We're going to create a new pizza. We're going to make it a large pizza. We're going to add pepperoni, but we're adding pepperoni twice. From the test name you might have picked up, we're handling duplicate toppings. And then we're going to add sausage. Then we come to the act stage. So when we say get toppings, we're going to store that value in toppings here. We're going to make sure that we see exactly 2 toppings, and those toppings should be pepperoni once and sausage once, meaning we know that that pepperoni, that second pepperoni, for this example, let's assume double pep is treated as a separate topping entry rather than just keep calling add topping pepperoni. We can verify that it did in fact deduplicate toppings, which is great. I mentioned this term a second ago, but system under test, it's an important term or concept to understand when you're talking about testing. This refers to the part of the application that we're testing. If you're writing a unit test, this would be the function that you're actually trying to test. If you're writing an integration test around a feature, it's going to be that feature. But as we write our tests, we want to be aware of what we're testing and then make sure that we're not trying to test other parts of the application within that. Because if something goes awry over there, suddenly it's going to look like, oh, the pizza topping deduplicator feature is broken, when really it was we were trying to, create pizzas in real time because the demand for pizza is just so very high. I'm not on my pizza game today, clearly, but as we write our tests, we want to try to isolate the system under test from the rest of our application. And when we are cognizant of what we're trying to test, we're much more likely to find the best way to test that thing, because we're not just looking at it as like, oh, it's this huge chunk of the application. We're saying, no, we're focused on this one very small part. And we'll talk more about things like test doubles later in the talk. So let's talk about PHP Unit. PHP Unit is by far the most popular framework or runner, or whatever you want to call it, for testing PHP. It's also easily extended by other frameworks. So the Laravel test runner, that extends PHP Unit. Tools like Codeception, they're going to use PHP Unit for portions under the hood. There are alternatives, such as Behat, which we'll talk a little bit about later, as well as Simple Test, which, as the name implies, is rather dumbed down. That's not putting it fairly. It's just very simplified. But PHP Unit is awesome, and I want to show you all sorts of cool stuff you can do with it. So, within PHP Unit, it's important to understand the structure as we go into it. At a high level, we're going to have one or more test suites, and these are going to be collections of test classes. If you're working on a default Laravel application, for instance, it's going to come with the unit and feature test suites, which correspond to the /test/feature and /test/unit directories that Laravel scaffolds. But you can create as many test suites as makes sense for your application. You might have your API test suite totally separate from everything else, but there are other ways to group things that I'll show you in a moment. Under the test suite, we have the test class, which is a literal PHP class. A test class is going to be a collection of test cases, and the classes are usually centered around a feature or a model. So if you have the pizza deduplication, or let's call it the pizza topping feature, you might have a class for like pizza topping test. Meanwhile, the pizza model may be, pizza test, something like that. Within that test class, then of course we have class methods, known as test cases. These represent single scenarios that should be tested within the application, and they're going to contain one or more assertions. Test classes are typically going to extend this PHP Unit framework test case class. This is shipped out of the box with PHP Unit. Great place to start and make sure that everything gets scaffolded the way it needs to. If you have a lot of shared functionality, if you need to, say, bootstrap a copy of your application and then set up a bunch of stuff before running your tests, you might consider creating your own test class. So in this case, we're creating my test class, which extends that base one, and then all of our tests are extending the base test class that we created. You could also do this with PHP traits. Again, it's going to be whatever makes the most sense for your application. Our test method are going to be public methods that are declared within the test class. By convention, these are going to start with the word test, although you can switch to, and this is actually how I've been moving lately, to the @test annotation in the doc block. And another thing that people have been doing, and I've really been digging it, being more descriptive in the method name and actually switching to snake case. I know, not PSR. You might have to tell PHP code sniffer, like, hey, chill out. But it does make it really nice when you can say, okay, I can tell it's a test, and it describes it should do something. It should acknowledge when a user does not have privileges to access this resource. It should prevent toppings from being added twice. So this is a really nice way to be descriptive in our tests. Now let's imagine a unit test for the get coffee function. I should have updated it to get tea for today, but alas. So let's say we have our function get coffee. We give it a size, a roast level, defaults to medium, and it returns an instance of coffee. So this is just kind of a nice helper if we need to quickly generate instances of coffee, as one often does. So within our function, we are creating an instance of coffee. We're calling the set size and set roast methods, and then we're just returning the instance. If we wanted to write a unit test around this, it might look something like this. I want to make sure I don't really have anything to arrange, so I'll skip to the act step. Coffee equals get coffee, large and light, and then I'm going to make some assertions. Assertions are where we're actually testing things within our application. So first I want to make sure that it's an instance of coffee, because I'd be really upset if I'm like, give me coffee, and it's like, here's hot chocolate. And I'm like, that's delicious, but not what I asked for. We want to make sure that it's a large coffee, because ain't nobody got time for small coffees. And I want to make sure that it's a light roast, because I told it I want a light roast. If I'm getting back a medium or anything else, something has gone awry. When I take all of these tests and I chain them together, PHP Unit's default runner is going to look something like this. In it, we can see this was Snap running PHP Unit 751, a total of 511 tests, 1,085 assertions, and 4 skipped tests. It took a total of 1.13 minutes to run through all of this, which even when you're like, 1.13 minutes, but how long would it have taken me to go in and manually test everything? This is awesome. And it occupied 42 megs of RAM. If something had failed, though, I would see something like this. I was expecting to see a large coffee, and instead I was given a small coffee. That will not fly. So it tells me exactly where it failed. It tells me how it failed. If we look at the test, I was looking for exactly assert same, large, get size. And it tells me it failed on line 14 in demo test. Really useful. With PHP Unit, we can configure it to run in all sorts of different ways. I won't dive too deep into this because it's XML and I don't like to look at it too long, or I go cross-eyed. But the phpunit.xml, or sometimes .xml.dist file, is going to tell PHP Unit how it should behave. Important things to note, it's often going to include a bootstrap file. If you're loading everything via Composer, you can just use vendor autoload. This is basically, let's load in everything it might need so then it can do what it can actually run all of the tests. We set up our test suites. Again, you're going to have at least one test suite. In this case, we only have one. It's unit. All of the tests for it live in test/unit, and all have the suffix of test.php. So that way we can have other things in there. If I have like testcase.php, well, that doesn't have a suffix of test, so I don't have to worry about that getting picked up and PHP Unit going, hey, there are no tests in here. We can also configure PHP if we need to set environment variables, if we need to say, hey, write to an in-memory SQLite database rather than writing to MySQL or Postgres or whatever you're using. We can do that here, setting the configuration for any time the test is run. So definitely helpful. PHP Unit gives us what are known as fixtures. Fixtures are going to run before or after, depending on which fixture you use, each test method. So setup is going to run before each test method, and tear down, you may have guessed it, will run after each test method. If we need to do something just at the beginning of a test class, we can use setup before class, which note that's a static method. and same with tear down after class. We can also do things with at before, at after, at before class, at after class. There may have been one more, but so we can create several methods. Now, one thing I found while working with Laravel, because the base Laravel test cases are already extending at least setup, if not also tear down, you'll typically want to call the parent constructor, or the parent setup method first within your setup method. Otherwise, you get into weird things where they're like, hey, this service provider isn't there because Laravel isn't booted, so it doesn't know what the hell a service provider is. So something to be aware of that's more Laravel specific. In practice, this might look something like this. Imagine we have a very complicated application. Instead of having to do all of this setup work, again, this abbreviated setup work, but imagine it's much more complicated than it appears. Instead of having to do this in each and every test method, we could just say, hey, I want to do this as part of setup, save it to this instance, and then everywhere where I'm actually referencing that instance, I can just use this instance sum method rather than having to create it at the beginning of each and every test. So fixtures can be super useful in that way. The @group annotation available through PHP-Unit is really helpful if you need to group tests that are of a similar nature but might live across different test suites or different test classes. If you're building something around, say, users, and you want to have all of your user stuff, yeah, the user model, maybe the whole test class of user test gets the @group users, but you also have some things that are like user profile screens and controller methods related to resetting passwords and stuff. Groups are very freeform in the way that they work. You can assign as many groups wherever you want. I also found out recently, kind of by accident, you can use the @ticket annotation, which acts as an alias for the @group, but @ticket it can be really nice when you're like, okay, I have this bug, I want to put a link to the GitHub issue or the Jira ticket if your team hates you. Does anyone like Jira? That's my joke for the day. Yeah, not a fan. But by using the @ticket, you could kind of say, okay, I added, a couple regression tests here. I fixed this bug over here. I'm going to add the @ticket annotation so then I can say, no, I can prove this works. Look at all of the tests that were associated with that. So that can be another way to kind of think of the @group. But it's sort of a free-form way to tag your tests, which is awesome. And they can be used concurrently at the method level or at the class level. To run these, I could do something like php-unit --group equals API, and no matter which test suites were configured, anything that was tagged as API as a group would run, and I could make sure that all of my API stuff was working as expected. All right, in the giant minute and 1.15 minute test run I showed you, there were a few skipped tests. This is what that's all about. So PHP-Unit lets us mark tests as incomplete or skipped. There's a very subtle difference between the two, and it's more in their meaning. Functionally, it's just not going to run the test. But in practice, when you say mark test incomplete, that's usually an indication of, okay, I was thinking through a feature, I was kind of saying, okay, I know I'm going to have to be able to accommodate this scenario and this scenario and this scenario, but I haven't had time to write it. Maybe you're not practicing full TDD, or you're just kind of scaffolding things out, but it's like a reminder of oh yeah, I need to come back and I need to fill out this test. As opposed to mark test skipped, which is usually okay, something's funky. I'm not quite sure why, but suddenly everything after this test starts failing, so maybe something's leaking data. Let me just temporarily remove this from the test runner. That's typically when you would do mark test skipped, more at a debugging stage rather than a development stage. If you see a production app with a bunch of mark test skipped, that could be a big red flag. So if you have issues and a bunch of skipped tests, maybe check out those tests. Oh God, let's hope my voice makes it through this. Data providers. One of my favorite features in PHP-Unit, and anytime I have to work in anything that's not PHP unit, I get sad. So data providers, oftentimes when we're writing tests, especially unit tests, we'll have things where we have the same exact setup over and over and over again, just different variables. So same scene, different actors. Data providers allow us to create a method like this called myDataProvider that's just going to return an array of test cases. So test my function, we say, okay, we're going to use myDataProvider, which corresponds to this. So this will get run twice. First, it'll get run with foo and bar as expected and actual, and then it'll be run with bar and baz as expected and actual, which is super handy because you can start building out this whole list, and especially when you're doing things like, hey, I want to make sure it doesn't like totally bork some URLs. You can go, let me think of every bad URL scenario I can think of, and then let it just run through and make sure I'm getting the expected value. What's even cooler is if you only need to use it for like one particular test, and you don't need it for like a bunch of different test methods, you can even use the @testWith annotation. So this is functionally the same, foobar, bar baz, foobar, bar baz, but we're able to add it just to the doc block. There are a few caveats here. It will only handle scalar data types. You can't do any variable interpolation. You can't refer to constants or anything in here. But if you just kind of have some dumb data and you're like, hey, I want to make sure that 1 + 4 is equal to 5, these can be really, really helpful. I mentioned test doubles earlier while we were talking about system under test. There are 5 types of test doubles. I doubt my friend Jessica Mauerhan is watching this on the live stream, but I gave this talk in San Diego back in September, and I only had these 3 listed. And she's like, yeah, Steve, what about the other 2? And I'm like, what do you mean, Jess? That was not a fun experience, but I learned. So it was a worthwhile experience. But there are 5. So first we have a stub. A stub is going to just set the response values. Basically, you're hard coding, hey, I'm expecting to call, this method, maybe it's calling out to an API or whatever. I don't want to actually call the API because that's not the system under test. I just want to say, when I call this method, these are the values I'm getting back. I'm not testing that thing. I've tested that elsewhere. I just want to make sure that I'm not getting weird data leaking in. A mock, on the other, is going to be verifying that an object behaves in a certain way. So you're saying, okay, I have this mock, and I expect it to call this method exactly 3 times with these arguments. We can do spy, which kind of flips the mock on its head, and instead of saying what did happen, you're saying I had expected this to happen, so hey spy, go watch this thing, and I'm going to ask you questions about it later. And I'll show you an example of mock and spy and how they work in just a moment. The other 2 that I missed the first time that helped lead to Jessica's excellent post, which is linked to from the slides. The dummy, something that satisfies requirements but nothing else. So let's say in order to instantiate a class that you're working, or maybe you have to create a user. You're not doing anything with the user, but the type hints say a user must be injected here. So you can't just say, oh, I'll just give it whatever. So you generate a user. The user's not doing anything. It doesn't matter what the user looks like. It just has to satisfy that user interface. And that's PHP interface, not user interface like UI. Finally, we have the fake. The fake is going to be an actual implementation of a system that you're not going to use in production. A good instance here would be when you're running your tests and you're using SQLite instead of Postgres or MySQL or whatever. It's something that you can inject. It's actually doing its thing, but it's not what you're using in production. Another instance might be if you have a logger that, say, maybe instead of writing out to actual logs, it's writing to like an array that you can check and make sure the error messages got logged. That would be a good instance of a fake. And again, that blog post is linked to from the slide README. A popular library ships out of the box with Laravel. kind of bastardizes the 5 types of test doubles because it really combines spy and mock in many cases, but mockery gives us this really fluent definition for mocks. So we could do something like, okay, I have an API class, and I want to mock my API class. I'm going to create a partial mock, which just means anything that I specifically tell you how to respond, do that. Otherwise, proxy it back to the original class. With my API mock, I should receive the getOrders method once. I could also define arguments, like I'm expecting to see exactly these values passed in. And it should return an empty array. So you can see where it's mixing the stub, which would be the return, and the mock, which is the should receive getOrders once. From here, we might make an assertion. So if we've mocked out part of our API and getOrders is returning an empty array, we can assume that getRecentOrders is going to be empty. Because if you have no orders at all in your system, chances are you don't have any recent orders. Spies, on the other hand, let us flip this a little more and adhere a little closer to that arrange, act, assert. So we create a spy, we say, hey, you're going to spy on the API class. We're going to then create an actual concrete instance of API. We're going to assert that getRecentOrders comes back empty, and then we're going to say, hey, spy, now that we've passed that assertion, we want to make sure that we did receive getOrders exactly once. This test does leave something to be desired because we're not actually specifying that like getRecentOrders will come back empty. We're just assuming. So honestly, not the best test. I'm going to update this before Longhorn. And it took me until I was sick to figure that out. Cool. But yeah, that's kind of how mockery works and spies and mocks in practice. Note that you can do these through PHP Unit without using mockery. Mockery is just kind of a nicer interface around it. I mentioned Behat briefly when we started talking about PHP Unit. Behat is more of a behavior-driven development testing framework. It's written to be very accessible to stakeholders. It uses a language that's known as Gherkin, which my understanding is became very popular in the Ruby world, thanks to Cucumber, which is a testing tool. I say was because Ruby changes out their tooling like every year or two. But the idea is that a stakeholder should be able to describe how a feature should work. You should be able to give the testing or the writing of the test to a business analyst or even to the client themselves. And they'll get something that looks like this. Given I am not an administrator, when I visit /admin, then the response code should be 403. Pretty straightforward. I mean, people would have to understand, like, okay, what 403 would correspond to and everything. But it looks a little familiar, doesn't it? It's almost as if it's secretly arrange, act, assert, but by a different name. What? Tools like Behat can be really cool. They seem really nice on the surface until you actually have to like write the regex to take care of parsing all of this and making real PHP out of it. Behat has gotten really nice at doing a lot of that for you. Like, hey, looks like you have this pattern and we don't have anything that matches it, so here's the pattern. Maybe you should write the implementation. But I would typically reserve Behat for integration tests and above. Tools like Codeception are nice because you can kind of say, okay, I want PHP Unit for the unit tests, but then as I move into the integration and end-to-end tests, I want something that's more Behat driven, for instance. But if you try to do unit testing with Behat, you might be in a world of pain. So let's talk about assertions, because at its core, or at their core, the concept of testing is all about assertions. PHP Unit is going to come with a ton of default assertions out of the box. It's also easily extended by frameworks. Or you can write, like I've written custom packages that basically work as like DOM wrappers, so that you can say, hey, I want to assert that I see this particular DOM element in here. because DOM document is a major pain. So let's take a look at some of the most common assertions. First of all, everything that we do is going to come down to a search for truth. So at the most fundamental level, we have assert true. Is value exactly equal, so triple equal, to the Boolean true? Assert false. Is it exactly equal to false? And as we go through more examples, you'll see everything kind of boils down to true or false. We can check equality. So assert equals expected and actual. It's just doing a loose comparison. Strict comparison if you do assert same. Be forewarned, if you are comparing two objects, assert same will only return true if they reference the exact same instance of an object. So you can't have like just two users, both are representative of user ID 4, but they're different instances. Those are not super equals. Assert same would fail, assert equals would pass. We can verify contents. If we have an array, for instance, of A, B, and C, does it contain the value of B? Why, yes it does, right there in the middle. We can do regular expression matching. Does the string foobar start with a capital F and one or more lowercase o's? Indeed it does. Foo is capital F, lowercase o, lowercase o. For most every assertion, we're going to have an equal and opposite assertion. This is typically going to take the form of assert thing and assert not thing. So assert equals, assert not equals. Assert contains, assert not contains. Assert array has key, assert array not has key. Assert count, assert not count, etc. As I said before, everything comes down to this search for truth. When we look at how the assertions work, everything comes down to, well, is this true or false? So assert equals, realistically, is expected double equals actual. Assert not contains. If we're working with arrays, we can say, okay, we're doing an array check on it. With regular expressions, we're doing a preg match and seeing if we have any matches. Everything comes down to that search for true or false, and that's really the key to understanding assertions. With PHP Unit, we can also test for errors, because errors, they happen. I'd like to know about them before the customer does. So, there are a few different ways we could go about this. The first thing, if we're trying to make sure that, say, a particular exception happens, we could just do a try-catch block. We might say, okay, I want to call my function. I want to catch the expected domain exception. Maybe I want to do some assertions on it. It should be a 500 error code. It should have this message of some error, and then I'll return early. If I don't fall into that catch block, I want to fail the test because I was expecting to see an exception and I didn't. And this will bite you if you take this approach to testing exceptions and you don't return and then fail if you don't catch the block, because you'll be like, everything's working, and it's like, no, the exception never happened. So these assertions were never run, so they could never fail. So honestly, it would just say, hey, this didn't perform any assertions. We can simplify this a bit. We can use the expect exception series of methods that are built into PHP Unit. So we can say, before we call some function, as part of our setup, we'll say, I want to expect a domain exception. It should have 500 as the status code, and it should have some error as a message. Exactly the same as what we did here, just a much cleaner interface. There's also the doc block method, which has now been deprecated in PHP Unit 8. But you'll likely see this out in the wild because a lot of people are like, yeah, this is so clean. Same thing, but we're setting it up in the doc block rather than within the method itself. So you can see we go from expect exception to expected exception. We can test output in our application. I come from a WordPress background, and WordPress is notorious for just sort of printing things to the screen. No, we're not going to return things. No, it'll just, you call the function and it echoes for you. Great. So when testing this, let's say we have a method here called greet. It takes the user's first name and it just does a printf. Not a sprintf with a return, straight up printf. Testing this, we can go about it a few different ways. Let's scaffold a user using just the user factory. We could use output buffering and say, okay, ob start, call greet, then ob get clean, which will take anything that was in the output buffer, store it to the output variable there, and then actually let things start printing again. And we could do assertions this way. We could clean this up by using set expected output. Again, we want to do it before we actually call the thing that would be producing the output, but we're able to say generate the user, set our expected output, and then greet the user. We can also do some regular expression matching here because sometimes output is not always going to be perfectly hello Tony. Also, anyone else really pumped for Endgame? I'm in a room full of nerds, so I assume yes. Yeah. They released a new thing yesterday, and I was like, yes! Best day to take a sick day. All right. So now that I've thrown like a ton of fundamentals at you, let's talk about some basic test-driven development. You may have heard the term TDD before, but if you're just learning how to test, it might seem like a really foreign concept. Like, whoa, I have to think through all of the tests before I could, what? So let's talk through it. So the basic workflow behind TDD, first we're going to write a failing test to describe the functionality or behavior. It could be a single test, it could be multiple tests. If you know, okay, there are other scenarios here that I need to account for. Maybe the user logs in and should see something, but maybe the user logs in as an admin and they should see something else. Or, whatever. This test that you write, or these tests that you write, are going to be failing because you haven't done anything to actually implement the code yet. It's okay, failure is good. So now that we have this failing test that describes how it should behave, then we can go and actually write the smallest amount of code necessary to make that test pass. So we've outlined our requirements, now we have to satisfy those requirements. Once we've satisfied those requirements, that initial satisfaction of requirements, it can be ugly. But now we have a test saying, okay, when you go in and you say, I'm going to throw all the functional programming at this, or I'm going to, pull in this library and I'm going to do all sorts of cool shit, it doesn't matter because you have a test around it, making sure that if that fundamental requirement ever stops working, the test is going to start failing. This is a practice known as red-green refactor. So we start with our red failing test, we get it to green, meaning the test is passing, and then we can refactor. If something breaks, i.e. it goes back to red, we know that we've broken the thing, and we can make sure to take steps to fix that. If you're not practicing TDD just from building a new feature, you might also consider adapting TDD for writing regression tests. So imagine we have this function. Again, it's a little WordPressy because it's echoing, sorry. If this posts array is empty, it's going to echo there have been no posts in the last 30 days. Otherwise, it'll say there have been X posts in the last 30 days. Pretty straightforward, right? So we run it, and we notice in production, there have been no posts in the last 30 days. Cool. 1 posts in the last 30 days. That's ugly. That makes me cringe. And then 2 posts in the last 30 days. Okay, cool. That is a problem. We don't want that. So someone opens a bug report, and we sit down as the developers and say, okay, I need to make sure that this is actually getting fixed because that makes baby dolphins cry. So we might write a test like this. Maybe we didn't have a test to begin with around any of this. So we decided, okay, great opportunity to use those data providers Steve told us about. We can say, here's the number of tests or the number of posts we want to create and what we're expecting to see. So we have some factory that we say, okay, generate this number of posts, set the expected output, and then call recent post heading with that posts array. We haven't changed anything in the actual implementation of the code yet. But now as we run this, we're going to see, okay, that passes the test. That does not pass the test because we were saying we're expecting to see 1 written out as a word, not a numeral. one post singular in the last 30 days. So this is still failing, and that's passing. But we've reproduced the bug in our test. So then we go, okay, maybe we throw in, an else if here, and if we have exactly one post, then we'll say one post in the last 30 days. Again, this isn't accounting for things like localization of text or anything like that. But now all of our tests are green. We can say this bug has been fixed. Maybe the test includes like an @ticket annotation pointing back to the Jira ticket because no one else is going to be able to find it any other way. And we have happy code, which is great. But then say someone comes in and they've been reading some BS and they're like, well, else if is an anti-pattern. We need to get rid of all else ifs. And they come in and they just remove that line because they're terrible people. Suddenly this test is going to start failing again because we've written a test saying, hey, this is how it should behave. And we fixed this bug. So this prevents these bugs from coming back. Or, put another way, from your code regressing. Haha, hence regression tests. So regression tests are awesome. And even if you're not practicing TDD as an overall practice, this can be a nice kind of gateway drug into TDD because you're like, okay, I'm going to reproduce the bug, which makes me have to think about how the bug is actually occurring. Then I'm going to fix the bug and know that it's not going to crop up again in the next sprint or the next time the junior dev comes in on his high and mighty BS. Not based on actual story, by the way. Or is it? Let's talk code coverage. So as we introduce automated testing, we can also generate code coverage reports, which are really nice. Code coverage is going to highlight what's not being touched by our tests. When we ran through our test suite, it touched 92% of the lines of code in this application, which means 8% of the lines of code were never executed throughout the entire test run. If you have bugs, there could be a good chance that it's maybe it's in the untested area. Or if you have a really critical feature and you're like, okay, if we don't have this working perfectly, we don't make money, and there's no test coverage, you have these big red lines saying nobody's tested this stuff. That could be a big red flag and a good indicator to your team that this is where we need to focus some attention. So no tests can imply, but don't necessarily indicate a higher level of risk in that application, or that area of the application. The question always comes up of test coverage, because you could have 0% test coverage, you could have 100% test coverage, or anywhere in between. This one is based on an actual story. I've had to work on an app before where they demanded, it was part of the CI pipeline, pull requests would automatically be rejected if it had anything less than 100% code coverage. And that was overall, not just on the changed lines, but the app had to have 100% code coverage at all time. A lofty goal, I'll give them that. And I had submitted a one-line change, and it was in a Python application. So I don't know Python. I realize that Python is supposed to be easy to pick up, but I'm sitting there okay, I was able to figure out how to do this one thing. Nothing functionally should have changed, but it was enough to trigger oh, well now it only has 99.999% code coverage. Boo, rejected. And I'm okay, can you show me how to write tests for this? And they're oh, yeah, we don't actually. And as I start looking through, it's I want to say the comment is pragma : no coverage or something. Basically, they just went through their code base and excluded a ton of functions and methods and files from code coverage so they could have that 100%. They were listen, 60% of the time, it works every time. Which was terribly frightening. It was awesome for only the sake of this slide. But my advice to you would not be to hide areas that aren't covered just for the sake of, oh, we have 90% code coverage. Yeah, great. But if you have 40% of your app just excluded from that, you don't have 90%. That's not how math works. So make sure that you're actually being honest about code coverage. 100% is nice. Doesn't mean you're not going to have bugs. At the same time, you don't want to be testing things that like don't really require testing. There are definitely going to be things out there where it's like, oh, this was a default broadcast provider generated by Laravel. A lot of times, it's still in your application. You might not be using broadcasting, but it's still there, and the test coverage goes, yeah, there are no tests here. And it's like, well, it was a generated file. We're not using it. Really, we should just kill it if we're not going to use it. But it's there, and then people get all like persnickety about it. So focus on solid coverage in the areas of the application that are important to you, your team, your company, etc. Are there any WordPress developers in the house? Am I the only one? Okay, Vince, you're getting dragged down here. So WordPress is this tightly coupled platform that doesn't lend itself well to proper unit testing. So it really drives me crazy when they're talking about, well, the core unit test suite. And it's like, unit testing. The fact that everything has side effects, the WordPress plugin API, which is one of its great strengths, really. But you say, I'm going to do this, and that fires off like 18 other actions that other things can hook into and change things, and it's just like, it's really hard to test any one part of WordPress in isolation. So, if you're a WordPress developer, Vince, be aware that it's not going to be a good example if you're like, oh, this is how unit testing must be done. WordPress is rarely like a solid example of this is how things are done in 2019. Maybe I shouldn't say who I work for. And within WordPress, the core test suite does what it can, but just don't look to WordPress as like, okay, great, this is how 33% of the web is being tested. We'll skip over the details specific to that, but know that, Vince, you can generate tests for plugins and themes via WP CLI, WP Scaffold plugin tests. It's that easy. Hooray. So with that, I want to thank you all for coming out. I know it was mostly for the pizza, but you listened to me for the last 52 minutes and 24 seconds. So again, my name is Steve Grunwell, senior software engineer at a hosting company called LiquidWeb. They're based out of Lansing. Please don't boo them because they're Michigan. Boo them because they hired me, and now Ohio residents have to pay sales tax because we have operations in Ohio. Yay.
I use LiquidWeb.
You use LiquidWeb. Awesome.
Personal project, yeah.
If I were drinking tonight, I would buy you a drink. But I told my wife I'd try to get home to put our daughter to bed.
I moved from Site 5 to LiquidWeb.
Yes. That's what I like to hear. And that joined in link is left over. Please disregard. Any questions? Yes.
So as far as your story into if you just you were born and you're unit testing day one as a baby, but I get a lot of these things, and then kind of start with functional tests because we had no testing, and then I work on web apps and I write unit tests, and then it doesn't integrate or you can do whatever. It's still failure. But as far as working your way into that, your team and whatnot, what's your story?
Okay. The story of getting into testing, zero to testing. We don't have TDD as a strict requirement. I make it a strict requirement for myself. Yeah. Kind of like, no, I'm not writing stuff without tests. I'm just not going to do it. Writing tests first has caused me to slow down, but in a good way, to not just go, let me just throw some code at it, but rather think through how the feature should really behave, especially since moving to the @test annotation and doing the snake case. That's been a really nice, no, I need to literally lay out anything, especially when writing a unit test, failure conditions or things where the project I'm working on right now, we are having to interact with several different APIs and bring all of that stuff in. But every time you bring in an outside system, that's another failure case you have to watch out for. And we're also dealing with a lot of like asynchronous processes where it's coming back and it's saying, oh, cool, here's an operation ID that you can go and look up to check the progress on it. So we want to get that into a proper broadcasting setup so that we can use WebSockets for it. But right now it's having to deal with polling and like what happens when that operation fails or whatever. My trip into testing came about from people going, oh, you should test. And I'm like, okay, I'll test. And some friends of mine maintain a library called WP Mock, which was written for a very specific purpose. They were doing a lot of work for TechCrunch. You may have heard of TechCrunch. And they were trying to write unit tests for everything, but using the WordPress core test suite, which means you're spinning up WordPress on every test method, which, you know, I use the WordPress core test suite with quite some success. But when you're on the scale of like 10,000 unit tests on your app, suddenly that can start getting a little slower. So they were doing a lot with how can we run more things in parallel, and this was several years ago, so it's while parallel processing within PHP was still like, holy, you're living on the edge. So they wrote this library called WP Mock that basically let you say, okay, I'm going to monkey patch WordPress to say, basically inject mockery into it to say, okay, I'm expecting this function to be called twice with these arguments, and it'll set up like actions and filters within WordPress and everything. I started writing some really bad tests around it, but I was getting 100% test coverage because I'm like, I've touched every line of code. My tests weren't effective. They were just describing the internals of the function. They were the implementation rather than the intention of the feature. So definitely test, you know, the intention, how things are supposed to behave, not the exact things. Because if you just write tests that say, I expect that it'll call this twice, and then it'll call this, and then it'll call that, sometimes that's useful. But most of the time you're just kind of like, I wrote the code twice, once in a way that's actually doing something, and once that makes me feel like I have warm fuzzies but doesn't prevent any sort of issue. The only real advantage coming out of that was like, I've had to go through everything twice, so there's a little bit of like a, oh, that was stupid, I should go back and change that. So I wrote a lot of bad tests for a long time, and then realized when I had to go back and refactor some things, like, these aren't helping me at all. What have I done? So back when it came out, I signed up for Adam Wathan's, is it Wathan? 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 That's out of left field. Okay. All right, so our good friend Canadian Adam's test-driven Laravel course. And as I was watching it, I mean, I was still doing more WordPress than Laravel at the time, at least as far as like percentage of my job. But it was a lot of like, okay, yeah, no, I'm approaching this all wrong. I'm writing tests to describe like what's going on in my app rather than what my app should be doing. So by putting the test before the actual implementation, that helped me kind of break some of that. Like, no, I have to write the test before I write this, so my tests aren't going to be filled with like, hey, it should call this one particular method with these arguments, because like, unless it's specifically necessary, it gets really messy. And that was also indicative of some big problems with the code that I was writing. I've since gotten much better about things like dependency injection, and the general idea of if your code is hard to test, if it's not very testable code, then that can be a code smell in itself. So once you kind of have some of these fundamentals and you're like, okay, I understand how my app is actually working, you're able to improve the way your app works, make it more testable, without testing being a painful thing. Does that answer your question? Basically, I just messed up a lot.
Yeah, that's what
All right, yeah.
At the beginning, but I think there's no good way around it except having, like, well, if your whole team, if you go into a team that has senior people that are already doing it, that's a good internship, but otherwise you have to look at
Well, the trick is, are the people who are doing it on your team actually good at doing it? Like, I've been a senior dev for years now. First time it was officially in my title was 2014. And I was doing this shit up until 2 years ago. So, I don't normally swear during conference talks. That's the S-bomb twice. I'm gonna blame the T. It's feisty tea. Any other questions?
Yeah, any thoughts on codeception? Does that make it easier or harder? And how well does it work with Laravel?
I'll be honest, I've only used codeception like once. I'm more of the PHP unit for unit and most of the integration tests. If I need something more browser driven, Dusk. Joe Ferguson gave a really great talk, it was 2016, I think, about codeception within Laravel. I think he's given it since. But if there are videos of that available, or if it's on Nomad PHP or anything, I'd recommend checking it out, because it was really like let's talk through like the role that codeception plays, the underlying tools that are being utilized, and kind of how that all comes together. So that was definitely like I should be doing that, but I was still writing shit tests at the time. So that's 3.
Thanks.
Anything else?
Leave a comment online.
Oh, what up,
Says,
online?
Nice job and thanks. Of course it was Josh.
Oh, hey, Krusty. Yes.
What about PHP spec? Have you ever looked into that?
I have not.
Okay, it's interesting.
Is it a replacement for PHP unit then, or?
Oh no, it's kind of like what's behavior-driven development. More
Okay.
Like that. So it's more like behat. So you right up. It ends up generating the stubs for the methods, kind of like behat. You
Okay.
Have the step definition on it, and you end up writing the code. Well,
Yeah. And I mean, TDD and BDD, so test-driven development and behavior-driven development, both have their merits. And it's kind of the spaces and tabs. People are like, oh no, you should use this, you should use this. And meanwhile, you just don't want to be the asshole who doesn't indent code at all. Pick whatever is going to make the most sense for you, your team, your customer, the tools that you like. Test suites will change over time. You might write one app using Behat, and then you might go, nope, we're going to go full PHP unit, we're going to go codeception, we're going to do PHP spec. But generally making sure that you're validating the behavior of your application. It's one of the keys to longevity, is having a solid test suite. If you've ever had to work on legacy applications, knowing how to test, coming in and saying, okay, what are some of these core things that, like, if these stop working, we have totally messed up and broken this application, and write tests around those. They can be end-to-end tests around them. You don't have to follow the automation testing pyramid for them, but making sure that you're able to, in an automated way, say, is this behaving the way that we expect it to? That can be really crucial, especially if you have multiple people working on, like, a legacy app. And they all have their own different ideas of, like, well, we're just going to rip this out. And someone is like, why don't we just rewrite it all? So I'll just start rewriting it internally. And it's like, oh. So, anything else? All right. Well, it looks like there's still pizza back there. I have not coughed on any of it, so you're welcome. And thank you again.